So finding the implied domain and range here, it's very similar to the worked example, I think worked example 10 where we did the graphing. So if we look at the first one, A, I've put here again just your domains and ranges for the various inverse trigs. It's off your formula sheet. So remember that this part here, the angle part, is or has to be between the domain that's stated for your inverse. So this has to be in between -1 and 1. Okay, so that's going to help us with our domain. The domain is always to do with the angle. In this case, it's x. Okay, so our domain is going to be linked with both of these. So we have to think about that. The range is always to do with what this entire value is here. Okay, and the range is always here. It's between -pi on 2 and pi on 2. It's pretty much contingent on whether there are any translations or any amplitude changes. Okay, so for us, what we're going to do first of all for our domain, we know that the angle 2x minus 1 has to be in between the maximal domain here, -1 and 1. What we can do is you can add 1 to each side. So we're going to end up with 0, 2x, add 1 to this side as well, gives you 2. Divide both sides by 2. So we're going to have 0 is less than or equal to x, which is less than or equal to 1. So that means that our domain for this particular function is going to be between 0 and 1. Our range, because we haven't got any translations or any dilations here out the front, or amplitude changes effectively, we're not going to be changing the range, but you can always check this as well. Put your maximum and minimums in here just to check if you're not sure. So inverse sine of 0 minus 1, that's inverse sine of -1. That would be -pi on 2, okay, because -1 is down here, so that's -pi on 2. And if you were to put your other value here of 1 in, you'd have 2 times 1, take away 1, which equals inverse sine of 1, which is pi on 2. So that makes sense then for our range to be between -pi on 2 to pi on 2. So our domain is x between 0 and 1, and our range is y between -pi on 2 and pi on 2. For B, this one here is to do with cosine. So we're going to do a similar thing again with the inverse cosine here. You can see that you've got here this 3, which is going to actually change the amplitude, change the range for the function. Okay, we'll do the domain first. So for our domain, we know that the angle 2 minus 2x has to be in between -1 and 1 for inverse cosine. So again, you could take away 2 from each side, so you have -3. Take away 2 from the middle, just leaves you with the -2x, -1. Now here we divide by -2. Remember, when you're dividing by negatives, you have to flip the signs around. So you've now got -3 divided by -2, leaves an x in the middle, -1 divided by -2. So we have 3 over 2 and a half. So that means that we've really got our domain between a half and 3 over 2. To finish off, I'll just erase this section here. We want to look at our range as well. Now normally cosine of 2 minus 2x, that part there would be ranging between 0 and pi in terms of its range. Yeah. But because we have a 3 out the front, it's going to be 3 times that range. Okay, so what that means for our range now is our range is going to be between 0 and 3 pi. So to finish, for our part B, for y equals 3, inverse cosine 2 minus 2x, we have a domain which is between a half and 3 over 2, and a range which is between 0 and 3 pi.